Welcome to this video on question number 9 from 2010 October November paper 4-1, which was a request of Messi. Let's get started. This question is on sequence. We are given the first 5 terms known as P1 to P5, and you can clearly see that in the next sequence they are just adding the next number. Yes, so in part 1 we want to find the sixth sequence known as P6, and it is really clear in the next sequence they will have the same number, and because for the sixth term they will add 6 more, so 6 more in 15 will give us 21. Yeah, so our next sequence will have a total of 21, and that's how they are building up. So it will be 1 plus 2 plus 3 plus 4 plus 5 plus 6 for the sixth sequence, so it will be 21. Let's see part 2. The formula for the nth term is of the sequence is Pn equals to half n bracket n plus 1. Show this formula is true when n is equals to 6. Now the n is the which term they are asking for. If they say n is 6, it means they are looking for the sixth term, and we have already calculated the answer should come 21. So let's check if this formula is really correct. So instead of n, I'm going to write P6 because I'm looking for the sixth term is equals to half. Now wherever I see n, I have to replace it with 6. Okay, so it will be half times 6 into 6 plus 1, and when you calculate this you will get 21. Okay, let's go to part 3. Use the formula to find P50, the 50th term of the sequence. So we will say P50, 50th term, is equals to 1 over 2 times n, and this time is 50, bracket open n, which is 50 plus 1, and you will get 1275. 1275. Okay, part 4. Use your answer to part 3 to find 3 plus 6 plus 9 plus 12 plus 15 to 150. Now this part is a bit tricky. There are 2 things you should know before we can start. First of all, the sequence is now different. Before we had 1 2 3 4, the sequence is now 3 6 9 12. They are multiple of 3. So this is my first term, my second term, my third term, my fourth term, and fifth term, and so on. So to find the number of term, so they are multiples of 3. To find the number of term, we have to divide the number by 3 to get which term they are looking for. So 9 divided by 3 is 3, 12 divided by 3 is 4. So which term is this one? Is 150 divided by 3 is 50. So this is the 50th term. The second thing which you should know in this question is that this means that they are looking for 150th term, because whatever the last number is it's the term they are asking for. For example, they wrote dot 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 4, it means they are asking for the fourth term. Dot 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 5, they are asking for the fifth term. For this one, because they don't have a lot of space to write every number, they wrote dot 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 150, it means they are looking for this term. And which term is this? Because they are multiples of 3, we have to divide it by 3, we'll get 50th term. We already know this, the answer for the 50th term for the sequence which has 1 2 3, and this is almost the same sequence, but it is a multiple of 3, so we can actually use this answer. That's why they said use your answer. So we have the total for the 50th term, but this time it's a multiple of 3. Okay, so we'll say okay, it's a multiple of 3. This was a bit tricky for you to understand, but you should get this. So it will be 3825. Okay, 3825. Let's have a look at the next part. Find, now this again we want the 50th term, and this is very simple, this one, because it is the same sequence which we have, so we can use the same formula now, which is P150 is equals to half times n. N is my 150 into n plus 1, which is 150 plus 1. Okay, and you will get what is 11325. Okay, this was easier than this, I think, and I think there should have been at least 2 marks. Anyway, let's see part 4. Use your answers to part 4 and 5 to find the sum of the numbers less than 150 which are not multiples of 3. Now when you read this you think, uh-oh, You cannot do this, but because they say we have to use our answers, so we have to find some connection between our parts in 4 and 5. Okay, what we have to find is the sum, and you can see these are the sum which we have been calculating. These are the sum of the numbers less than 150. It means up to 150, and we have already found the sum up to 150, right? This is the sum, but they say they should not be multiples of 3. So we will find the sum, but we will remove the multiples of 3, which is this, which we found, right? So the sum of multiples of 3 we found, we have to remove from the sum which we already found, including all the numbers. So this is the sum till 150. This is also the sum of 150, but just the multiples of 3. So from this, if we remove this, we will get what they are asking for. So it will be 11325 minus 3825, and that's how we'll use our parts 4 and 5, and you will get 7500. Okay, now let's see the next part. Part B. Again we have a bit different sequence, and we have to work out the next term as 6 in the sequence. Easier way is that you can just copy, and you can just say 1 times 6 now plus 2 times 5 and so on. You can just write, if you want, 3 times 4 plus 4 times 3, then you have 5 times 2, and then finally I have 6 times 1. Yeah, it's a bit stretchy. So you will end up by 56. Okay, this will be my 6th term, and in the next part, again like our part A, we have to just confirm if our 6th term is correct. So I will say S6 is equals to 1 over 6 times n, and this time is my 6 into n plus 1, which is 6 plus 1, n plus 2, which is 6 plus 2, and by using your calculator you will get 56. Okay, for the next part, now again we have to see the last term, because this is the one we are looking for, because this is, it means 4th term, 5th term. The last one we say, okay, they want us the 20th term, right? So we'll say S20 this time. 20th sequence is equals to 1 over 6 times 20 into 20 plus 1 into 20 plus 2, and you will get what is 1540. Okay, part C now. Show that S6 minus F5 is equals to P6, and what is P6 is part A1. What is part A1 is that 56. Okay, so our answer should come up to 56. Let's see. Part A1, sorry, I have to go back to part A1, not B1. I saw B1. Part A1 is 21, so answer should come up to 21, and it should be simple. Let's see. I already have my what do we call, S6. This is my S6, 56. So I will say 56 minus S5. Let me just calculate S5. S5 will be my 1 over 6 times 5 into 5 plus 1, 5 plus 2, and it's coming to 35. So it will be S5 is 35. This will be equals to 21, and yes, it is my part A1, which was 21. Now I have this final part. Show by algebra. So we have to use algebra. There is no other way we have to solve this question, that Sn minus Sn minus 1 is equals to Pn, where this is the Pn. I think overall this question is a good practice. It has a mixture of sequence and algebra. Yeah. So okay, so Sn minus Sn minus Sn is the simple formula which we know, which is 1 over 6 times n plus 1 and n plus 2, this is n, sorry, and minus Sn minus 1. So wherever I see n, I will replace it by n minus 1. So this will be 1 over 6. Now instead of n, I will write n minus 1. Okay, that's the deal. So the other one will be n plus 1. So I will say instead of n, I will write n minus 1 plus 1. which will be n. And the other one, again I will say, instead of n I will write n minus 1. The other one was plus 2. So that's how our equation will be. Let me just simplify it a little bit. It will be n plus 1, n plus 2, minus 1 over 6, n minus 1, n, and n plus 1. Okay, minus 1 plus 2 is 1, minus 1 plus 1 is nothing. So I just have to use algebra, solve this, and it should come to this value. Okay, let's see if I can solve this or not. Okay, now some of you might open the bracket and it becomes a big equation, but we have to go here, and you can see they haven't really opened the bracket, right? So I will not open the bracket. In fact, I will see what are common and I will almost factorize it. Okay, so what's common? 1 over 6 is common. Yes, let me just use a bit different color. 1 over 6 is common, n is common, n plus 1 is common, n plus 2 is not common, and n minus 1 is not common. So whatever the common, I will take it out of the equation, and I will have is 1 over 6. Sorry, it's a very thick one. 1 over 6 n and n plus 1. The common I have written. Now I will open a big bracket, and I will see from the first part what I have taken out is already gone. So 1 over 6 is gone, n is gone, and plus 1 is gone. What's left is n plus 2. So I will have n plus 2. Okay, now from this whole I have finished. I have n plus 2 here. Now from this one I have again taken out 1 over 6. It should be a negative, and I have already, no, I have not taken out n minus 1. Let me write n minus 1. Already gone, already gone. So this is the what is remaining, and you can cross check. You can, if I multiply this with this, I will have this again, and if I multiply this with this value, I will have this value again. So I have done the factorization correct. Now it's just a matter of solving. So if I open this bracket, what I will have is n plus 2 minus n plus 1, and this n will be cancelled with n. 2 plus 1 will become 3, right? It will become 3. So finally I will have, what I have is 1 over 6 times n plus 1 times 3, and 1 over 6 times 3 will give me 1 over 2. So it will be 1 over 2 n and n plus 1. Okay, and let me check if this is what we were looking for. Yes, this is what we are looking for. Thanks for watching.